Hi, welcome to this video. In today's video, we would like to write a Python program to find those numbers which are divisible by 7 and multiplies of 5 between 1,500 and 2,700, both included. So we would like to write such a program. In order to write such a program, first of all, we need to define the range. So the starting point is 1,500 and the ending point is 2,700. Okay. Now, in order to find the numbers that are divisible by 7 and multiplies of 5, we need to have a for loop because we need to iterate through all the numbers between this number and this number. And then if they are divisible or multiply of 5 and 7, we are going to print those values. One important point to consider here is that we are saying that we want those numbers which are divisible by 7 and multiplies of 5. It means that it should pass both conditions, not either of them. If we were looking for either of them, we had to have or word here instead of and. So when we are having and, it means that both conditions must be true. Okay, now we know what we want. We're going to have a for loop saying that for each variable num in the range start and end plus 1, because we know that when we are having a for loop, the starting point is inclusive, but the ending point is exclusive. So when we write down the end, which is 2,700, it is going to loop up to 2,699. Okay, so the end point in for loops is exclusive. So range, starting point, ending point. Okay, so the starting point is inclusive, but the ending point is exclusive. So we're going to start from the starting point 500, sorry, and the ending point we want it to be 2,700. But if we write down this number there, it is going to go up to 2,699. Therefore, we need to add 1 here to have the full range. Then we check if that number is going to be divided by 7 and its remainder of this division equals 0, it means that it is divisible by 7. Yeah. So one condition to understand if a number is divisible by 7 or not is the following. So a number is divisible by 7 only if that number is divided by 7 and the remainder of this division equals 0. In this condition, we know that that number is divisible by 7. So if a number is divisible by 7 only if that number is divided by 7 and the remainder of this division equals 0. In this condition, we can say, okay, that number is divisible by 7. So this we are checking here using the modular operator, because we learned that using modular operator, we can understand the remainder of the division between two numbers. And because we were having the division by 7 and multiplies of 5, therefore we need to have the AND operator here. And here, in order to check if a number is multiplied of 5 or not, again we are going to do the same test. If a number is multiply of 5, that number, when it is divided by 5, the remainder of this division must be equal to 0. Also, we can say a number is a multiply of, for example, 5 only if that number is divided by 5 and the remainder of this division equals 0 again. In this condition, we also understand that number is a multiply of 5. So if a number is a multiply of 5 only if that number is divided by 5 and the remainder of this division equals 0. So we are using modulo operator to check this. So if this number is divided by 5, the remainder equals 0. So if both of these conditions are true, because we are using AND operator, print that number for me. It means that that number is also divisible by 7 and multiplies of 5. So print that number for me. And this is the message I'm going to print. Here we are saying that numbers divisible by 7 and multiplies of 5 between 1,500 and 2,700 is the following, for example. And then we are doing this for loop to and in each iteration we are going to understand if that number is divisible by 7 and multiplies of 5. If yes, print that number. If no, go up and go for the next iteration. So when I run this code, we see that, for example, numbers divisible by 7 and multiplies of 5 between 1,500 and 2,700. These are the numbers: 1505, 1540, 1575, 1610, 1645, etc. until the end. And the numbers that are not printed out here, they are not they are not divisible by 7 and multiplies of 5 at the same time. This is why we don't have them in the print here in the output. Thank you for watching. So in this video, we learned how to print numbers that are between two numbers. So we discuss how we can find if a number between two other numbers, so the numbers between, for example, 1500 and 2700, all of them between this range, we considered if a number in this range is divisible by 7 and at the same time a multiply of 5. Thank you for watching. Welcome back. In today's video, we would like to write a program to construct the following pattern. This is the pattern that we would like to have, and we need to write a program to do this for us. So we see that it's a repetitive pattern. So we are having star being printed in different lines. We can either do it manually. For example, we can have this print star. We can have this. And then in the next line, we can have the print. Now 2 stars, for example, with a distance, etc. until the end. But it's not a very efficient way of doing it. In order to do that, we learned that repetitive tasks are very good to be done using loops. So we are going to use loops here in this example to do the job for us. So first of all, we see that what is the maximum number of rows that we see here. So we are what is the number of columns that we are having here. So here it's only one column. Here we are having first column, 2 column, third column, fourth column, and the 5th column. So we are going to have up to 5 columns. So in one row, first we are having 1 star. In the next row, we are having 2 stars. In the next row, we are having 3 stars. So the maximum number of stars that in one row we can have is 5. This is why we are having our n equals to 5. The maximum stars that are there in one single row is 5. So we are having n equals to 5. Now, let's start the work. We said that for repetitive tasks, it's better to use loops. Here we are going to have a for loop with our iterating variable I for each I that is in the range of 1 and n plus 1, because we learned that when we are having the range, the starting point is inclusive, but the ending point is not inclusive, okay? Therefore, we are having the ending point, which is 5 plus 1 here. And in each iteration, we are going to print the star with the repetition with the number of I. What does it mean? It means that, for example, when I equals 0, when I equals 1, sorry, because we are starting from 1, print 1 star, okay? But if I equals 2, print 2 star, 2 star, with 1 space between them. Why? Because we are having it here. So we are having a star and then a space multiplied by I. It means that whatever the value of I is, multiply it with this. Okay, so this is going to be printed as large as the value of I. If I equals 1, it is going to be printed once. If I equals 2, it is going to print it 2 times, a star with a space. Okay, if it's 3, it is going to print the star with a space 3 times. Therefore, here, when we are having the I equals 1, we are having 1 star being printed. When we are having I equals 2, we are having 2 star being printed. And then it goes up, increase the iterating variable, I equals 3, it is going to print 3 stars, then 4 stars, until it is 5 stars, okay? So now let me run the code. We see that in the first iteration, we are having I equals 1 because the starting point is 1, we are having 1 star. Then I equals 2, we are having 2 stars, 3 stars, 4 stars, until the end 5 stars, because we are having the endpoint exclusive. 5 plus 1 is 6, and we are going to have therefore up until 5 inclusive, and we are going to have this print. So this print is the first half of the pattern. Okay, so this part is now created. Now what we need to do is to have a for loop, another for loop to print us the stars, the remaining stars, and in each iteration, now instead of increasing the number of stars, reducing the number of stars. Okay, so in order to do that, we are having the second half iteration, an iteration for the second half of the pattern. So we are having a for loop for each I in the range n-1 and 0. So it is going to start from 4. Let me have a comment here. Range. So it is going to start from 4, and it is going to continue up until I equals 0, but because it's inclusive, it is going to go one number before that, which is 1. And in this iteration, the point is this. We are going to reduce the iterator variables. So by default, I, when it is equal to 1, in the next iteration, it is going to be 2. In the next iteration, it is going to be 3, etc. But when we indicate that this number, the third argument, we are going to start from 4, I equals 4. In the next iteration, I will be equal to 3 because we are reducing one value from it at each iteration. In the next one, I equals 2. In the next one, I equals 1. And we are going to stop there. Why? Because the ending point is 0 and the ending point is exclusive. So the last number before that is when I equals 1. Okay, so we are having a for loop for each I in this range, starting from 4, ending at 0 exclusive, and in each iteration we are going to reduce the value of I by 1 unit. Then in each iteration we are going to print again stars to the number of I. For example, when we are having 4, I equals 4, we are going to have the 4 stars with 1 space between them. Then in the next iteration, I equals 3, we are going to have 3 stars. Then I equals 2, we are going to have 2 stars. Then I equals 1, we are going to have 1 star. But why we started from n minus 1? Because already we have the row which has 5 stars, which is here in our pattern. So the next row is having 4 stars. So the next for loop that we are writing should have the starting point from the 4. So this is why we choose n minus 1, which is this number. So we want to start from 4 because we already have this row with 5 stars. We're going to have the 4, and in each iteration we are going to reduce the value of I up until it reaches to ending point 0 exclusive. So now this pattern will be created when we are having this for loop. So if I run the code, we see that the second half of the pattern is now also created. So the first part, for the first half of the pattern, we use the first for loop, and for the remaining part of the pattern, we use the second for loop. Here we saw that we started from 4 stars, then 3 stars, then 2 stars, and finally 1 star. So in this video, we learned how we can use for loops to construct this pattern instead of manually printing these stars. So now this way, everything is easier. Thank you for watching. Hi, welcome back. In today's video, we are going to write a Python program that asks a user to enter a string, and we would like to reverse the entered string by the user and print the reversed version of that string, or let's say phrase. In order to access inputs from the user and store it, we are going to have this line of code. We are going to use the input function. We are saying that enter a word, and whatever they are going to enter, we are going to store it in the word variable. And simply, when we want to reverse a word, we are going to use slicing. In order to reverse a word, we need to write down the name of the variable, and then we are having colon -1. This way, the compiler is going to directly start reversing that string for us and assigning it to reversed word variable now. And finally, it is going to print the reversed word, which is this message. First of all, is shown using the print function reversed word colon, and then the reversed word is shown here. So this variable that we reversed is shown here. So let me run the code. So when I run this code, it says enter a word. I would say Reza, for example, and I enter. It says the reversed word is Azer. So A, Z, E, and R. Exactly from the end, it starts to reversing our string. So let me try another example here. Reza Shahin. So I enter. It says NIHAHS space. Even the space is there. And then the rest of the work is there to reverse our word, our string, let's say. So if I have a phrase, what would happen? For example, this is the Python online course that we are having here. So it's, first of all, it's our original phrase. This is the Python online course that we are having here. And now you see that it starts from the last word and starts reversing the last word, then the one to last, two to last, etc. So you see that instead of here, we are having this word. Instead of having, we are having exactly this word. So having ends with ing, it starts with G and I VAH, so VAH, and then we are having the era instead of the R, and we are having EW instead of V, and all of the words are reversed here. So in this video, we learned how we can get one string or a phrase from the user and then start reversing it simply using this methodology. So we write down the name of our string that is holding the string inside of it. So the word variable is having the input string from the user. Then we write it down and simply we are having colon -1 starting to reverse our string from, and it is going to basically the compiler is going to start reading our string from the end. So this is why we are using -1. -1 is the index of the last letter in our string. So it is going to start reading our string. For example, if my string is, for example, Reza. Okay, when we are having the indexing, so the index is 0, 1, 2, 3. So for letter, I'm providing the space so I can explain it easier. So for letter R, the index is 0. For letter E, the index is 1. For letter Z, the index is 2. For letter A, the index is 3. Okay. Also, it can be this way. Okay, -2, -3, and -4. So here we see that letter A is also having the index -1. Letter Z is having the index -2. Letter E index -3, and letter I index -4. Therefore, when we are using this methodology, basically the compiler starts reading from the last letter of our string, which is also having the -1 index. So the compiler starts reading from here for each word. And when it is going to read from here, it is going to also store it, and now we are having the output which is reversed, because instead of having the Reza, now the compiler is seeing AZER because it is reading it from the end, from the -1, then -2, -3, and -4 until it reaches the starting point, which is R now. Okay, so this is how the compiler treats a reversing, and after reversion, it is assigned to reversed word variable, which is another string, and then we are printing it here in the output. Thank you for watching. Welcome to this video. In today's video, we would like to write a Python program that prints all the numbers from 0 to 6, except for 3 and 6. Okay. In order to do that, the one method is to print, for example, 0, then print 1, etc. until the end manually. But we learned that if we are doing repetitive tasks, it's important to use for loops. So now I would like to use for loops here. Here is my for loop. So for each num is my iterating variable. For each num that is in the range between 0 and 7, we are looking for numbers from 0 to 6, but because we learned that the ending point is exclusive, so we are going to have between 0 and 7, and 7 is exclusive, so it is going to include up until 6. If num equals 3 or equals 6, simply continue. And if this statement is not true, print that number for me. So when I run the code, we see 0, 1, 2, 4, and 5. And 3 and 6 are not being printed. So let me analyze the code for you. Num is my iterating variable here. Okay. So in each iteration, num is going to take one value. First of all, num is going to take value 0 in the first iteration. When num equals 0, what happens is the following. It checks to see if num, which is 0, equals 3. No. Is it equal to 6? No, it's not equal, because this condition is not true. Therefore, this block of code, which is one part of the if condition, is not going to be executed, and then it is going to come here. Using the print function, we are going to print that num, which is 0, that we see here. Okay, and this end keyword helps us to have all the prints in one line rather than having them in different lines. So if I remove this, for example, when I run, you see that they are not in one line. They are in different lines. Okay, so when I have this, everything is going to be printed in one line and with a space. Okay, so you see it here. In the first iteration, num equals 0, and we're going to have the 0. Then num equals 1, and we are going to, in the next iteration, 1 equals 3. No. Is it equal to 6? No. Therefore, we're going to go to the print again. We're going to print 1 and put 1 space. Then num equals 2. 2 equals 3? No. 2 equals 6? No. Therefore, we're not going to go to this part and we're going to print. Simply, we are saying that, okay, 2 is printed with 1 space. After that, we are having num equals 3. Here in the next iteration, num equals 3. 3 equals 3? Yes. And because we are using the OR operator, we are not even going to check this part, because when we are having OR operator, either of the conditions must be true. So we don't care if it's the first one or it's the second one. If one of them is true, we are going to have the result to be true. Okay, so whenever we are, let me review it here for you. Whenever we are having the AND operator, both conditions must be true to enter it. Okay, when we are having the OR operator, however, one of the conditions must be true to have the true output. To have the true output. Okay, so when we are having AND operator, both conditions must be true to have the true output. But when we are having the OR operator, one of the conditions must be true to have the true output. So we are having the OR operator, and one of the conditions, either this one or this one, must be true. And num equals 3 means that 3 equals 3, so it's true. Therefore, we are going to continue and execute this part of the code. So when this condition is true, we are going to say, okay, so we enter this if condition, and the code in the if condition is continue, meaning that do nothing, skip. Okay, so nothing will happen, and we are getting out of the if, and we are going to increase the num one more time. So we are having num equals 4. This is why when num equals 3, nothing happens actually. When num equals 3, we are using the key word that is continue, meaning that, okay, carry on, skip, and do nothing. And when we say continue, okay, it is going to go for the next iteration where we are having num equals 4. So num equals 4, we enter the this part again. So 4 equals 3, no. 4 equals 6, no. So this part is not executed, and we are printing 4. Then num equals 5, we are having this condition is not true because 5 is neither equal to 3 nor to 6. We are going to print 5. And finally, we are having num equals 6. So we are saying that num equals 3, no. Or num equals 6, yes. Therefore, continue, enter this part and use the keyword continue. So we are going to continue and do nothing, skip. This is why nothing is being printed here in the output when we are having that num equals to 6. And this can be true for many other situations. For example, we can have num1 in range, for example, between 0 and 101, let's say between 0 and 100 we want to investigate, but because the ending point is exclusive, I'm saying 0 and 101 colon. Then we check, for example, if num1 divided by 2 equals 0. In this situation, print, for example, the number is even, and we can have this condition here. So when I run the code now, we see that, okay, let me also print the code. Okay, we see that the number is even, the number is even. So also I need to have the num1 in each iteration, so it is going to show me which number is even. So when I run the code, it says the number is even. It's 2, 4, 6, 8, 10, etc. until the end, you see. So we see that here I'm having a for loop from 0 to 100, and if that number, that iterating variable in each iteration is divided by 2 and the remainder of this division equals 0, it means that that number is even, and we are going to print that number. So this is another exercise combining the concept of for loop and if conditions. Or we could say if it was divided by 7 and the remainder of the division equals 0, it means that that number is divisible by 7. So we can say divisible by 7. So if we want to print the numbers that are divisible by 7 between 0 and 100, we can run this code. We see that all the numbers that are divisible by 7 are printed here in the output. And also we could say, for example, if the number is divisible by 7, continue. Do nothing. Okay? Otherwise, print the number for me. So, print the num, and we are going to have also the end keyword to have all the numbers in one line. So when I run the code, okay, we are having a very large range, so we are having a lot of output. Let me reduce the range. So when I run the code, we see that, okay, here let me first comment this part. So now if I run the code, we see between the range of 0 and 50, all the numbers that are divisible by 7, we're not printing them here. And we are printing all the numbers except those that are divisible by 7. Okay, we see 1, 2, 3, 4, 5, 6, 7 we don't have. Then we have 8, 9, 10, 11, 12, 13, and 14 we don't have. 21, for example, we don't have. 28 we don't have, etc. until the end. So this is how we can combine the concept of for loops and if conditions in order to check certain conditions and continue and skip and do nothing in certain conditions and do something else in other conditions. Thank you for watching. Welcome back. In today's video, we would like to write a Python program that accepts a string and calculate the number of digits and letters. For example, when I run the code, it says enter a string. I write down Reza Shahin, and it says the number of letters, it's 10, and the number of digits it's 0. Okay, so we would like to write a program to calculate number of letters and digits. Okay, in order to do that, first of all, we're going to start with this message. We're using the input function to show this message to the user, enter a string, and then we are going to ask the user to enter a string, and whatever the user is going to enter, we are assigning it to text variable. We are having two counters here, letter count and digit count. So we are going to initialize them to be 0 because whenever we see a letter, we are going to increase it. So this way we are counting the letters and digits. Now we need to have a for loop. So in order to have a for loop, we are having our iterating variable, which is called char. So for each char in the text, this is the variable that we stored the string that we got from the user. If that character is a letter, increase the value of letter count by 1, and if that letter is a digit, if that character, let's say, is a digit, increase the digit count. And we are going to use the is alpha and is digit function to do that. Basically, this function is going to help us to see if one character is a letter or it's a digit. So in order to understand if a char is a letter, we can use the is alpha function, meaning that, for example, if the name of my character is char, like this, char dot is alpha is going to tell us the answer is true or false. If it's true, it means that this character is a letter. If the output is false, it means that this character is something else. It's not a letter, let's say. So here, in order to check if one character is a digit or not, we are also going to use the is digit function. Okay, so here we are going to check to see if that specific character is a digit or not. If character is digit, this line of code is going to return true for us. If that character is not a digit, it is going to return false for us. So here we are iterating through each character of my string here, text, and checking each character one by one. So I say that character, in the first iteration. For example, let me run the code one more time. I say my string is Reza. It says we are having 4 characters. Let me say Reza 1. Okay, it says 4 characters, 1 digit. So now let's see how it works. In the first iteration, my character equals R because my string is Reza 1. Okay, in the first iteration, the char equals R. And then we check to see if R is a letter. What is the answer? Yeah, it's true. So because this statement is true, we are going to enter the if condition and we are going to increase the value of letter count by 1. So letter underscore count plus equal 1, meaning that we are going to increase it. Then in the second iteration, char equals E. And we are going to check if this character, which is E, is a letter. Yes, yes. Therefore, we are going to increase this value again. We are going to have letter count. Another time it is increased. So here, letter count was equal to 1. Initially, it was 0 because we initialized it here. Okay. Then after this iteration and doing this, it became 1. Now after the character E in the second iteration, we are increasing the number of letters. Now it is also increasing by another 1 value, so it becomes 2. Now we are having the character. What is the next character? This is Z. Okay, character equals Z. We check to see Z is a letter. Yes, the answer is true. So we are going to increase this value again. We are going to increase this value one more time. Therefore, the number of letter counts now equals 3. In the next iteration, we are going to have char equals to 1. We check to see if char is a letter. Yes, so we are going to increase the letter count one more time. So now it's equal to 4. And finally, the last character is this one. Okay, is this one, 1. So we can have char equals 1. So we this time, when the character is 1, we check this part. If the character is a letter, the answer is no. It's false because it's not a letter, it's a digit. This time, my character is getting the value 1. Therefore, because this statement is not true, it's not going to execute this part. It goes and check the next condition. Here, we are checking to see if our character is a digit. Is it a digit? Yes, the answer is true. Therefore, we are going to increase the value of digit count. Therefore, here the character equals 1. So digit count plus equal 1, meaning that the digit count equals 1. So now we iterated through all the characters of my string and we calculate the final number of letter count to be 4 and digit to be 1. So after finishing this for loop, we are having the number of letters in the output. We are using the print function. So letter count is being printed, number 4. This is exactly what we expected. This is what we calculated. And also, we are seeing that number of digits. So it is digit count. So it is 1, which is exactly what we had here. So this is how actually we can get a string from the user. We can initialize the counters for letters and digits, and then we can loop through the string that we got from the user, and each character can be investigated one by one to see if it's a letter or if it's a digit. And in the end, because when it is a letter, we are going to increment the value of letter counter. If it's a digit, we are going to do the same. We are going to increase the counter. And in the end, we are going to print the letter count and digit count. Thank you for watching. Hi, welcome back. In today's video, we would like to write a Python program to check if a triangle is equilateral, isosceles, or scalene. So first of all, we need to know what are these triangles. Let me review the definitions. So a triangle is equilateral if all sides are equal. Okay, so a triangle is equilateral if all sides are equal. For example, side 1 equals side 2 equals side 3. So, for example, side 1 is 5 centimeter and side 2 and side 3 are also 5 centimeters. Therefore, side 1, for example, equals 5, side 2 equals 5, side 3 equals 5 as well. It means that side 1 equals side 2 equals side 3. When we are having this situation, we call our triangle equilateral. Now, we call a triangle isosceles if a triangle is isosceles if two of the sides are equal. Okay? It means that, for example, side 1 equals 5, side 2 equals 5, and side 3 equals, for example, 10, for example. So these two sides are equal. This is why that we can call this triangle isosceles. Okay, so two sides are equal. This could be side 1 and side 2. This could be side 1 and side 3. This could be side 2 and side 3. So if any of the two sides of a triangle are equal, we are going to call that triangle isosceles. Okay. Then we are going to have the scalene triangle, meaning that neither of the sides are equal. So a triangle is scalene if neither of the sides are equal, meaning that side 1, for example, equals 2, side 2 equals 3, and side 3 equals 4, for example. In this situation, we are going to call this triangle a scaling. So we would like to write a Python program to check if a triangle is equilateral, isosceles, or scaling. And we reviewed these three definitions to have a better understanding of what it means to have a triangle that is equilateral, a triangle that is isosceles, or a triangle that is scaling. Okay, now, first of all, we are going to ask the user to enter three numbers. So we are going to use the input function and ask the user to enter side 1. We are going to save it as a float because when we are using the input function, by default, it's a string. We're going to convert it to float and assign it to a. We're going to do the same thing with side 2. We're going to use the input function to get it, and then we convert it to float and assign it to b. And side 3 is also goes through the same procedure and is assigned to c. And now, in order to understand if a triangle is of the type 1, 2, or 3, we need to define a function. This is our function, check triangle. In this function, we are going to check if the triangle is equilateral, isosceles, or scaling. But before that, we need to check the sides of our triangle to see if they are valid or not, because it means that when we are having the addition of two sides, it must be larger than the third side. Okay, the third side, yeah. So for example, a plus b must be larger than c, and a plus c must be larger than b, and b plus c must be larger than a. This is a general rule for sides of triangles of a valid triangle. So first of all, we are going to check this. If this part is true, we are going to call the check triangle function. Otherwise, if this statement is not true, it means that we are not even having a valid triangle. We need to revise it, and this message is shown. The given sides do not form a valid triangle. Okay, so we imagine that we are going to enter inputs that is a valid triangle. We are going to call the check triangle function, and we are going to pass three arguments, a, b, and c. So the check triangle function is called using three arguments, a, b, and c. So we check to see if the sides, all of them are equal. So a equals b equals c. If this statement is true, we are going to print this message. The triangle is equilateral. Okay. But if this statement is not true, so this part is not going to be executed. And we go for the next condition. Elif a equals b, or b equals c, or a equals c. So here we check to see if any of the two sides of the triangle are equal. So a equals b, or b equals c, or a equals c, because if any of these conditions is true, it means that we are having an isosceles triangle. So we check all the sides 2 by 2 if they are equal. If we at least have two sides that are equal, it's an isosceles triangle. Okay, if all of them are equal, it's equilateral. So we check a with b if it's equal or not, b with c, or a with c. If any of these conditions, any of these three conditions is true, we are going to enter this else part, and we are going to this elif part, and we are going to print this message. The triangle is isosceles. Otherwise, if neither this condition nor this condition is true, it means that the triangle is scaling. So we are going to print the scaling message in the output. Okay, so this is how we can check the type of our triangle. So let me run the code first. It says enter side 1, I say 5, enter side 2, I would say 5, enter side 3, I say 5. So all of the sides are equal. We expect to have this message: the triangle is equilateral. So when I enter, it says the triangle is equilateral. So we call the check triangle function, and we see with these three arguments, and then we check here a equals b equals c. Yes, so the triangle is equilateral. Then this message is shown. So if I run the code one more time, so 5, 6, and 7, when I run the code, this time it says the triangle is scaling. Why? Because we are having a triangle and neither of the sides are equal. So 5, 6, and 7. The first one, all of them must be equal. The second one, two of them must be equal. And if neither of them are equal, it's scaling. And finally, we are having, for example, another triangle, which is 5, 4, and 5, let's say. And this is a triangle of type isosceles. So this one. Why? Because the first side and the second side, both of them are the same number. So here we check A equals B, 5 equals 4, no. B equals C, 4 equals 5, no. A equals C, so 5 equals 5, yes. Therefore, it enters and checks here. The triangle is isosceles. So in this video, we learned how we can write a program to check if a triangle is of type equilateral, isosceles, or scaling. Thank you for watching. Welcome back. In today's video, we would like to write a program to count the number of characters in a string. In order to do that, I would like to define a function that is going to do the counting of each character. So in each character, frequency is counted inside this function, char frequency. What I'm going to do here is the following. For example, when I run the code, it says enter a string. So I write down Reza, for example. When I enter, we see that it says R, the frequency is 1, E, the frequency is 1, Z, the frequency is 1, and A, the frequency is 1. So our program counts the number of frequency of each character. When I run the code one more time, I type down Reza R, for example. This time it says we are having two R, one E, one Z, and one A. So here, first of all, I ask the user to enter a string. We use input function to get the string from the user. We assign it to text. Then we are having the call of the function of the char frequency. This is the name. And we are passing text variable as an argument of this function. And the output of this function is assigned to variable called frequency, okay, which is a dictionary. But let's see what's happening inside this char frequency function. When we call this function, the compiler comes here. It checks the name of the dictionary, sorry, the name of the function, and okay, so this is the function that was called. When this function is called, this part of the code is going to be executed. So first of all, we are creating a dictionary to store character count. And as a reminder, when we are having a dictionary, we're going to have key values. Okay, so a dictionary is having key value pair. It means that, for example, for the key1, we are having value 1. Then we are having, for example, key2 and key2. Then we are having value 2, for example, etc. Okay, so just imagine that we are having a dictionary with two keys and two corresponding values. So it's a key value per a dictionary. We are having the key 1, its corresponding value, key 2, its corresponding value. Here exactly, if you see that R is my key and its corresponding value is 2. So in a dictionary, we can easily count the number of frequency for each character. Now I created an empty dictionary here. Then we are looping over the S. So for each character that is in S. And what is S? S is exactly what we passed as argument to call the function. And what did we use to call the function as an argument? This is the text, which is what the user entered. So the entered string by the user is stored in text. We pass text as an argument for the char frequency call of function. Here we just name it s, and we are now looping over the string that the user enters. So we are looping over the string that the user entered. Okay. Now that we are looping over each character of a string that the user entered, just imagine the string is Reza R. Okay. Now, for example, in first iteration, character equals R. So we are looping over R. Then in the next iteration, character equals E, character equals Z, equals A, and equals R. So in each iteration, we move forward character by character. Now we are saying that for each character in the string, if character is inside the frequency dictionary, what does it mean? It means that, for example, we are checking to see now that in the first iteration, char equals R, okay? We want to see if R is in frequency dictionary, okay? In order to check that, we need to check the keys of my dictionary. And first of all, in beginning, initially, this dictionary is empty. So when in the first iteration, when we are having the character R and we are checking to see if R is inside the frequency, the answer is false because initially it's an empty dictionary. So there is nothing inside that. Okay. Now that this statement is not true, we are not going to execute this part of the code and we go to the else part. When we go to the else part, now we are having the value of that character in the frequency dictionary equal to 1. Okay, so we are creating one element for the frequency dictionary here. So what's happening here is the following. So now frequency dictionary is having one key and its corresponding value. Okay, let me repeat it one more time. So what's happening here is the following. So first of all, we started by looping over the string that the user entered. So we are having the character by character, we are looping over the string. For example, if the string is Reza R, first we start by R. We check if R is in the frequency dictionary. The answer is no, because initially it's an empty dictionary. So this part of the code is not executed. We go to the else part. Here we are creating a key for this dictionary, which is R, and we assign its value to be 1. Okay. And after this has been implemented, we go up, we move to the next character, and next character is now E. So now the next character is E here. Okay. So now We check if E is in the frequency dictionary. Now our frequency dictionary has one key and its corresponding value, which is R and 1. So E, is it inside the frequency? No, because we only have R, so this part is not executed. Then we move on to the else part, and we are creating a key with the name E, and its value is 1 in the frequency dictionary. So now the next one is created, which is E, and its value is 1. Okay, so we go for the next character now. Next character is Z. So Z, is it inside the frequency? No, because here we only have R and E. So we go to the else part, and we are creating another key which is called Z, and its value is 1 in the frequency dictionary. We do the same with A. So A is not existing already there. We are creating one uh, and assign it to the A key. Now that we are going to the last character, the last character is R. So we check R, is it in the frequency? Yes. Now the answer is yes, because we already have one R. So in this case, we are going to increase its value by 1. Okay. So we are going to increase the value of the R key in the frequency dictionary by 1. So it is already 1. We are going to increase it by another 1 unit, so it will become 2. Okay, so let me repeat the last part. We are going to have the last iteration. So the last iteration is over R. We check to see if R is already there. Yes, R is already there. So R is there. So this statement is true. We check to see if this character is already in the frequency dictionary. Yes, therefore we are going to increase the value of R in the frequency dictionary by 1. So it was already 1. We are adding another one. It will become 2. This is how this function is going to count the number. So the number of frequency of each character. So in this frequency dictionary, now I have R equals 2, E equals 1, Z has the Z has the value 1, and A has the value of 1. So A, Z, E, and R, they are my keys. As we said, it's a key value pair, and it's 2, 1, 1, and 1. It's their corresponding value. As we expected here, we saw the same thing in the output. So we were here. So here we called the function. We did all this computation, and in the end, we are returning the dictionary frec, okay, or let's say frequency. We are returning this dictionary. So we created this dictionary and we are returning it now, okay, and the return dictionary is assigned to this frequency variable, which is itself a dictionary. Now we would like to display character frequencies. So everything is inside this dictionary now, frequency, because the output of the function was assigned to this variable. Now we are having that. We are looping over characters and values. Let's say we call count here. These two are my iterating variables, character and count. And they're going to iterate over the keys and values respectively. Okay, keys and values, keys and values. For example, this char iterating variable is going to iterate over all the keys R, E, Z, A, and this count variable is going to iterate over their corresponding values 2, 1, 1, and 1. Okay, in frequency.items, when we are having the frequency.items, frequency is the name of the dictionary. .items means that the items function is going to help us to iterate over the keys and values. Now, in each iteration, we are going to print the character with its corresponding value. So in each iteration, we see R, for example, and its corresponding value is 2. So R is my character, its corresponding value is 2. We're printing it. Then in the next iteration, we are having E and 1. So E and 1, Z and 1, and A and 1. So this way, we are having a function to count the frequency of characters. And also in the end, to display these character frequency, we are using a for loop to iterate over key and value pairs of my dictionary. So in this video, first of all, we reviewed the dictionaries, we reviewed how they are created, and we learned that a dictionary is a key value pair, and then we learned how to count the number of frequency of different keys in a unique dictionary. After that, we learned how to iterate through key value pair in a dictionary. Thank you for watching. Welcome back. In today's video, we would like to write a Python program to get a string made of first and last two characters of a given string. So if the string length is less than 2, return empty string instead. Or we can say, or a message, return an error message. Okay. So here is my code. When I run, it is going to return the first two and last two characters of a given string. For example, I'm calling the function using this string Python. What I get in the output is pyon, so the first two characters and the last two characters. I called it using hi Reza. I say I get hi, the hi and za in the end. And when I call the function with the string less than two characters, I'm going to get this message. It must have at least two characters. Okay, so this is my code. But how can we do that? So here I'm having a function called first and last two. It accepts one parameter. Whenever we call this function, we need to have one parameter. So here I call this function first and last two with the argument Python. So I'm calling the function with a string. Here, first of all, in the function, I check to see if the length of the argument that is passed to call this function is less than 2 or not. So if it's less than 2, we are going to return this message. It must be at least 2 characters. Okay? So if the length is less than 2, it is going to show this message. But if it's not less than 2, we're going to return this part. And what is this part? Basically, this part is having a new string being returned with the first two characters and the last two characters of the S string. So for example, if my string is Python, here what's happening in the return, it is returning the S2 plus S minus 2. Okay, and basically this part is going to create a new string that is py, which is the first two characters of my string Python, which is py, plus the last two characters, because we are having the index minus 2. Okay, so the last two characters plus on. Okay, so this one will become pyon in general in the end. So this is what we have as the output, as you see here. But why minus 2? So if I have a string here, let me give you another example. If I have a string called Python, the indexing works like this: 1, 2, 3, 0, 1, 2, 3, 4, 5. So this is the indexing. So index of the P character is 0, index of Y character is 1, etc. until the end. The index of N is 5. So the character N has the index 5. We also have another method for indexing a string. We can start from the end. So when we start from the end, the last one is -1. For example, the character n, the index is -1. Then the character o, the index is -2. Character h, index is -3. Character t, index is -4. Character y, index is -5. And finally, the character p, its index is -6. So we can either count from left to right for indexing where we are having from 0 until 5, or we can count from right to left, which will have this way. So n equals -1, o equals -2, etc. See, this is the indexing of our characters of this string. So when we are having the string s, the first two characters, it will be index 0 and 1, which is p and y. And when we are having the -2 and then colon, it means that from the start from the -2, which is o, and go until the end, which is o and n. Okay, so this is how we can have this. So -2, it will be o and n. If I write down -3 and then colon, it means that it starts from h and continue until the end. This is how we can create a string from the first two letters and the last two letters. Thank you for watching. Welcome back. In today's video, we would like to write a Python program to change a given string to a newly string where the first and last characters have been exchanged. So what we are doing here is the following. I'm having, for example, a string called Python, and in the output, we see that the first character, P, and the N, the last character, they have been exchanged in the output. So n is now my first character and p is my last character, while the rest of characters remained the same. You see it here. Yeah. So also this happens for the hello. H and O, they have been exchanged. We see O is my first character, H is my last character, and the rest of the characters are the same. And if we are having a character with less than 2, length of less than 2, let's say, we're going to have this message, not long enough, not long enough. So what we are doing here, first of all, we are calling the swap first last function. And this function, what is it going to do? It's going to create a new string, and it is going to exchange the first and last letters. So swap first last function, we are calling it with an argument s. Here when I call this swap first last function, I'm having a string as argument that is passed. Then we check if the length of the passed argument is less than 2 or not. If it's less than 2, we're going to have this message being shown, not long enough, exactly as we have here. But if the length is larger than 2, we're going to return this part. Because this statement is not true, then we're going to go here and execute this part of the code. So what this part of the code is doing. So my string is hello, let's say. Okay. This part of the code is saying that s with the index -1. So the character with the index -1 of my s string, and this is my string. The character -1 refers to the last character, okay? Character with the index -1 refers to the last character. So create a new string where the first character is O because we are putting it in the beginning. So the first character is O. Why? Why O? Because we are calling the string with character of index -1, and character with the index -1 is O. In the S, for example, a string which is hello. So the last character, which is having the index -1 of my string hello, is O. Okay, so I write down O here, plus, then we are having a new separation, let's say. So we are having now character from 1 to -1, and the ending point is exclusive. So we are writing it down like the following: from index 1, which is E, until index O, which is the -1, but the end is exclusive. Therefore, we're going to be having this. Okay, and why we are having index 1 from E? Because when we are having a string like hello, the indexing starts from 0, 0, 1, 2, 3, and 4. Okay, this is my indexing. And now H is having index 0 and E is having index 1. Okay, so from 1, which is the starting point, and the starting point until ending point. But we need to be very careful. Ending point is exclusive. So ending point is exclusive. We are going up until -1, but -1 is not included. Okay, so we start from 1, which is E. We go up until -1, but because it is not included and it is excluded, uh, we are not going to have that. So we are having ELL. Okay, so ELL plus. Now we are having the index 0 of our string. So we mentioned that this string hello, the index 0 is the first character, which is H. So here is my H now. So now we are creating a new string with these characters. So O, E, L, L, and H. Okay. So this is how we are going to exchange the first letter and the last letter. Also here, I'm having another example for Python. The same happens here. So we are going to, let me write it down here. So we are having a string called Python. First, we are putting the last character, which is N, plus YTHO plus P. Why? Because we are saying first the last character, which is N. So we are putting it here. Then start from the character with index 1 and go up until character -1, but the -1 is exclusive. So this is index 1, which is Y. Go up until -1, but -1 is exclusive. So we go 1 to the left. We are having the YTHO as we have here. And finally, we are having index 0 of the string s. So index 0 of this string means that we are talking about the first character here, which is P. So now we created a string that is like this: NYTHO and P, exactly as we see here in the output. And in case that we are calling the swap first last function with any string that has the length less than 2, we are going to have not long enough message because it's less than 2. So the length of the character is measured through the len function. If it's less than 2, if this statement is true, we're going to show this message not long enough. So in this video, we learned how to exchange the first and last characters of a given string. Thank you for watching. Welcome back. In today's video, we would like to write a Python program that creates a function. And this function is going to check if a given string is palindrome or not. So palindrome means that it reads the same backward as forward using Boolean values. So here is my string. So you see that when I read the string madam from the left to right, it is madam, and if I reverse it, it will be madam again. So this is what we call palindrome. So reads the same backward as forward. Okay, and also here, this word is also a palindrome. So race car is my string, and if I read it from the right, which is RAC, which E race, and CAR race car. So from right when I read it, it's race car. From left when I read it, it's race car. However, the word hello, it's not the same. So when I read the word hello, from left it's hello, from right it's something like ole. And for example, for the next word, which is level, if I read it from left, it's level, and if I read it from right, it's also level. And finally, we are having the Python. So if I read it from left, it's Python, but if I read it from right, it's not Python. I'm not sure even how we can pronounce it. Nofip, something like this. So this is how we can understand if a string is palindrome or not. In order to understand this using Python, we write down a function that is called isPalindrome. And in this function, whenever we call this function, we are passing one argument. So we call this palindrome function with one argument called s. So whenever I call this function, I'm having one string. So the string is madam here. So is palindrome race car. So whenever I call this function, I'm having one argument being passed. So in this function, first of all, we use the def keyword to declare our function. This is the name of the function, and this is the arguments of the function. And in this function, we only have one argument. So in this function, what we are checking here is the following. We check to see if the string s equals to s when it is being reversed. So it checks to see if s string equals to its reversed version, and its reversed version is colon minus 1. Okay, s colon minus 1. This is the reversed version. Whenever I want to reverse a string, I'm going to do this. Okay, so now because this function, let's say this code will help me to reverse my string, I'm checking to see if my original string equals its reversed version. Okay, so here we check to see if it equals its reverse version. And when I call this isPalindrome function with the madam string, or let's say argument or parameter, the output is true. Why? Because the original string, which is madam, is equal to its reversed version. Then we are having the race car, it's also true, but for hello, it's false. For level, it's true. For Python, it's false. So one thing here to mention is the following. So for example, if I have my string equals Reza, okay, this is my string, then my new string equals my string colon minus 1. So now print the reversed string is, then I would like to have my new string being printed. So when I run this code, you see that my original string is Reza. I want to reverse it. So now that I want to reverse it, I create a new string called my new string, and my string, which is Reza, is reversed using colon minus 1. And now I'm printing my new string, and you see that it is reversed. Other. It's the reversed version of Reza. Okay? So this is how we can reverse a string. So here we are exactly doing the same thing. In this function, we are having the original string and checking to see if it equals its reversed version. If this part is true, if they are equal, we are going to have the true in the output. If they're not equal, we are going to have the false in the output. So in this video, we learned how we can check if a string is palindrome or not. Thank you for watching. Welcome back. In today's video, we would like to write a program that calculates whether a person is eligible for voting based on their age or not. Here is my function. So it is called can_vote and it needs one argument. And whenever we call this function, therefore, we need to have one argument. And for example, here, I'm calling the canVote function with the argument 20. So I'm passing this argument to the canVote function to check if this person with 20 years old can vote or not. Also with the age 18, also with age 16. So we're going to have three inputs to check whether the person can actually vote or not. So here, whenever this function is called, this code is executed and checked, investigated, let's say, these if parts. So first of all, we are checking to see if the age that the user entered or the age that we are investigating is larger than or equal to 18. If so, if this condition is true, it means that we are eligible to vote because this is the only condition that we are defining here. So this person is larger than, it's more than 18 years or equal to 18, that person can vote. So we're calling the function with number 20. We check to see, okay, 20 is larger than 18. Yes, so you are eligible to vote. So when we run this code, we see this message here. You are eligible to vote. Then we call the function with number 18. And 18, is it larger than or equal to 18? Yes, you are eligible to vote. Therefore, this message is also printed in the output. However, when we call the function with a number that is lower than 18, because this is the criteria for checking if someone can vote or not, we are calling a function, we are calling the function with a number lower than 18, for example, with 16. We check to see 16, is it larger than 18? No, it's not true. Therefore, this part is not executed and the else part is executed. Because whatever that is not inside this condition is going to fall into the else part. And this message is shown. You are not eligible to vote. You need to wait 18 minus age. So 18 minus the enter age, which will be 18 minus 16, so 2 more years. So you need to wait 2 more years. So here you see you are not eligible to vote. You need to wait 2 more years. So this is how we're going to have the output. So now if I want to have another input, for example, can vote, and in parentheses, I write down, for example, 10. So we want to check to see if someone with the age 10 can actually vote or not. So here we're calling the function 10. Is it larger than 18? No. So this part of the code is not executed and we fall into the else part and we see this message. You're not eligible to vote. You need to wait 18 minus 10. It's 8. 8 more years. So when I run the code, you see that we are having this message. You're not eligible to vote. You need to wait 8 more years. So this is how we can actually combine the concept of functions and if conditions in Python to check a simple condition. If the person is older than 18 years old, or the person is 18 years old, the person can vote. Otherwise, it's not possible and they need to wait. And how much they need to wait? The difference between their age and the number 18. Thank you for watching. Welcome back. In today's video, we would like to write a Python program that creates a function. And this function is called factorial. This function needs to calculate the factorial of a number that is a non-negative integer. So whenever I call this function, I need to have an argument being passed. So here I'm calling the factorial function and I'm having one number, for example, number 5. It means that I would like to calculate the factorial of 5. So here, when this function is called, n equals 5 in this part, and 5 is it lower than 0? If it's lower than 0, show this message, invalid input. Please enter a non-negative integer, okay? However, if it's not lower than 0, do the following. Assign a new variable, initialize a new variable called result, and it is equal to 1. And define an iterating variable, which is I. So for each I that is in range 1 and n plus 1, and we know that the ending point is exclusive, so we are having the range, starting point, ending point. And the ending point is exclusive. This is why we are having n plus 1, okay? So actually it is going to go start from 1 and goes up to n. And in each iteration we are going to have the results equal result multiplied by I. So this formula exactly equals this formula. So if you think that this one is easier to understand, you can simply write it down. The results will be the same because they are the same thing. So in the first iteration, I equals 1, we are going to have result equal 1 multiplied by 1, and therefore result equals 1. Why 1 multiplied by 1? Because we are multiplying result by I, so result is 1. And in the first iteration, I is also 1, so result is 1. Then we are having I equals 2. So result will be 1 multiplied by 2. Result will be 2. Why? So we are having result multiplied by I. So result is 1 because from previous iteration it's 1. And I equals 2. So it will be 2 here. Then we are having I equals 3, for example, we are having result equals 2 multiplied by 3, 2 multiplied by 3, so now result will be 6. But how? Because we are having result multiplied by I, so result is 2 from the previous iteration, we have it. And also I equals 3, so we are having number 3 here, 2 multiplied by 3, it's 6. Then we are having I equals to 4. Result equal 6 multiplied by 4. So result is 24. And finally, in the last iteration, we are having I equals 5. So result 24 multiplied by 5. And the result will be 120. So result will be 120. So in the last iteration, we are having result multiplied by I. So result from previous iteration is 24 and I is 5. So we are having 24 multiplied by 5. It means that we are going to have the result equals 120. And because now I equals 5, we wanted to continue up until n plus 1, and n plus 1 is exclusive. So n was 5. Oops, sorry. So n was 5. We were supposed to go from 1 to 5 plus 1, which is 6. So 6 is exclusive. So we are going to go up until 5. So I is going to start from 1 and it is going to continue up until 5 because we wanted to calculate the factorial of number 5. Okay, so after finishing this loop, we are going to return the result, which is 120. So we are going to return it and therefore print this because we called this function with the argument 5. So it is going to return the result. So we are going to have the print 120 in the output. And next time I call this function with number -3. So when I call this function with number -3, it comes here. We check first of all to see if -3 is lower than 0. The answer is yes. So we are having this message being shown in the output. Invalid input. Please enter a non-negative integer. So this is why we see this message in the output. So basically in this code, we learned that we can have the calculation of different numbers factorial. For example, we can have factorial of, for example, 3. And when I run this code, we see that the factorial of 3 is 6. The factorial of, for example, 10. Let's calculate this one. So this one is this number, okay? We can have the calculation of factorial of 6. It's 720. So this is how we can have the factorial of any positive number using this factorial function. Thank you for watching. Welcome back. In today's video, we would like to write a Python function that takes two Boolean values as input and return the logical and or of those values. So here is my example. I have my two Boolean variables a and b. One of them is true, the other one is false. And we want to define a function that checks the relation between these two, the and or. Okay, so here is my logical operations function. So this is a function called logical operations. It requires two arguments, a and b. So whenever I call this function, I need to have two arguments, a and b. So here I try to call this function logical operations a and b. Then we are assigning the result of this function to and value and or value. So we are having two variables on the left hand side, meaning that this function is going to return two values for us. Here you see this is the function output. So the first output, the second output. So the first output is going to be assigned to the and value. The second output is going to be assigned to or value. So this is how this function works. We're calling the function with two variables. On the right hand side, we are having the call of function. On the left hand side, we are having two variables. It means that this function is going to return two values for us, and or. Okay, so it is returning also two values. After doing the calculation by this function, these two values are assigned to add and or values. Finally, we are showing the and value and or value. So what does this function do? Logical operations. Two variables, let's say two arguments are required for this function. So a and b. First of all, we are checking the relation between a and b. So a and b, the relation is either true or false. It is assigned to and result. A or b, the output can be true or false, and it is assigned to or results. But the question is when it is going to be true, when it is going to be false. So when we are having a equals true, b equals false, when we are having the AND operator, both conditions must be true to have an output of true. Okay, so when we discuss AND operator, if both of them are true, the result is true. So let me write it this way. True and true, it's true. True and false, it's false. False and true, it's false. And we are having false and false, it's false. So when we are discussing the AND operator, both of the conditions must be true so that we can have the output to be true. You can see it here. So true and true, so the output is true. But if one of the conditions is false, for sure the output will be false. So when we are having true and true, the output is true. But when we are having true and false, the output is false. When we are having false and true, the output is false. When we are having false and false, the output is false. So when using the AND operator, the only situation in which the output will be true is when we are having both conditions to be true. Okay. But what about the OR operator? So when we are having the OR operator, when we are having true or false, the output is true. When we are having false or true, the output is true. When we are having false or false, the output is false. And finally, when we are having true or true, the output is true. So, however, when we are discussing the OR operator, at least one of them must be true to have an output of true. Okay, at least one of them must be true. So we are having true or false because we are at least having one true, the output is true. False or true, the output is true. False or false, the output is false. And true or true, the output is true. So this is the review of and OR operator. Now we are having the A equals true, B equals false, and we would like to check A and B. So true and false. So true and false, the output is false. So the output of this will be false because one of them is true and the other one is false. And in order to have the true answer, we must have both of them as to be true. So now one of them is false. Therefore, the output is false and it is assigned to AND result. Then we are having A or B. We are having A or B, true or false. And this one is like this, true or false, because at least one true is there. So the output is true and it is assigned to OR results. Then we are returning these two values, AND results and OR results. We are assigning to AND value and OR value. And then we are printing the output. And in the output, we see the AND result is false as we expected, and OR result is true. So this is how we can have a function that takes two Boolean values as input and return the and OR logical and or of these two values. Thank you for watching. Welcome back. In today's video, we would like to write a Python function that accepts a string and counts the number of upper and lower case letters. So here is my string, hello world, and I'm calling a function called count upper lower. This is the name of the function, and I'm passing my string as argument. And on this is the right hand side. On the left hand side, I'm having two variables. This again shows that we are having a function that is going to return two values. Okay, so when looking at this function, this is my function, this is what's happening inside the function. As we see in the return part, we are having two variables as the return part. So the first one, upper count, is assigned to upper, and the lower count is assigned to lower. And finally, we are printing the upper and lower letters. So in the output, we see for the hello world string, we have two uppercase letters, which is H and W. Then we are having the lowercase letters, which is 8. But how can we do that? So this place is where we call the count upper lower function, and we pass the string as argument. So when this function is called, we are having two variables being initialized. So upper count and lower count, both of them are initialized to be 0. Then we are having a for loop in order to count the uppercase and lowercase letters. We can do it manually, but it's hard, so this is why we use for loops. In order to do that, we are having a for loop iterating over s, which is the argument, which is here the text, and text is holding our string. Okay, so we are iterating over this string character by character. In the first iteration, we are having H. In the second iteration, we are having E. In the third iteration, we are having L, etc. until the end. So in the first iteration, let's say, let me write it here. First iteration, character equals H, okay? And we are checking to see if that H is uppercase letter. Using the isUpper function, we can understand that. If this statement is true, add one value to the upper counter, which was initialized to be 0. So H is an upper letter, so add one value to the upper count. Therefore, the upper count now is 1. Upper count is now 1. Okay, so we continue with the rest of the letters. Now that we want to continue with the rest of the letters, in the second iteration, we are having the char equals to E. Okay, so now char equals to E. Here we check if E is uppercase letter. Is it true? No, it's not, because it's not uppercase letter. It's lowercase. Therefore, this part is not executed. We go here, so we check if E is lowercase letter. Yes, the answer is true. So we are adding the one value to the lower count variable. So lower count is now equal to 1 as well. Okay, so this is the lower count now. So we go for the third iteration. For the third iteration, we are having the char equals to L. Yes? Okay, so char equals to L. We check L, is it uppercase? No, so this part is not executed. L, is it lowercase? Yes. So now that it's lowercase, we are going to add another one value to lower count. So it was initially 1, now we're going to, initially it was 0, then it was 1, and now we added another one, now it's 2. And this way, we are going to continue the iteration over the remaining characters of this string. Therefore, we are going to keep track of the uppercase letters and lowercase letters. And finally, that we finish the for loop here, we are having the updated upper count variable and lower count. So basically the upper count should be 2 because we are having only H on W, and the lowercase letter should be 8. So in the end, it will be 8. And finally, we are returning these upper count and lower count variables, which are assigned to upper and lower variables respectively. Finally, we are showing them in the output here. Thank you for watching. Welcome back. In today's video, we would like to write a Python function to check whether a number falls within a given range or not. So here is my number, num equals 10. We are here calling the isInRange function here, and we are passing 3 arguments. First of all, we are passing our number, which is 10. Then starting point and ending point of our range. So we would like to see if this num is inside this range or not. And again, I call this function one more time, and I would like to check the same num to be if it's inside this range or not. This is how we're going to proceed with the program. So isInRange function is called with 3 arguments, number, starting point, and ending point. And finally, in this function, we're going to do a work that is very straightforward. We're going to check if this number, which is the first argument, okay, is larger than or equal to the start, which is the second argument, the starting point, and at the same time it is lower than or equal to the ending point, which is the third argument. Okay, so this is going to return either true or false. If this statement is true, meaning that the number is between these two ranges, so it is going to return true for us. If this number is not passing these two conditions, so it means that it's not larger than or equal to start or and lower than or equal to end, it is going to return false. So when I run the code, first of all, we see true. So we are passing number 10, 5, and 15. Basically here we are checking to see if number 10 is lower than or equal to 15 and it is at the same time larger than or equal to 5. This is what we are checking here. Okay, and the answer is true. Indeed, 10 is larger than 5 and lower than 15. So it is going to return true. This is true for us. Then we are having the same number being checked being checked to see if it's between 11 and 20. So here we are saying 11 and this is 10 and this is 20. Okay, so here we check if 10 is larger than 11 and lower than 20. It is lower than 20, but at the same time it must be larger than 11. So it's not, therefore it's not going to return true, so the output is false. It's like AND operator. Both of the conditions must be true to have a true output. For example, we could have another example here is in, for example, 21 and 30. So when I run the code, the answer is false because we check to see if 10 is larger than 21 and lower than 30. Yes, it is lower than 30, but it's not larger than 21. This is why the answer will be false again. So this is basically how we can check to see if a number is actually is falling within a given range or not. Thank you for watching. Welcome back. In today's video, we would like to write a Python program to count the occurrences of each word in a given sentence. So here is my sentence. Hello world, hello everyone. This is a word of coding. This is my sentence. And in the output, we see hello is being repeated 2 times, word is being repeated 2 times. So hello and hello, word and word is being repeated 2 times. And the rest is being repeated only 1 time. So everyone, this is a of coding. Everything is being repeated once, apart from hello and word. But how can we count that? In order to count that, here I'm creating my string called sentence. I call the count word function and pass sentence as its argument. Then here we are creating a new variable, let's say a new string, and it is assigned to the argument that we passed, and we use the lower function and a split function. So the argument that is passed is my sentence. So this sentence using the is lower is first of all converted to lowercase letters. All of them are converted to lowercase letters. Then we are having the split function to convert this sentence into words. Okay, they are separated now by a space. So we are using the split function to have a list of words instead of having one sentence. This way we can count to see if one word is being repeated or not. Okay, so first of all, we are doing the lowercase. Second of all, we are splitting the sentence into words. So this is, and then it is assigned to words here. Okay, so now in the words, I'm having a list of words, a list of my strings. Okay, and for example, one element is hello, the other one is word. Hello everyone, this is a word of coding. Each of them is a different and unique element in these words. Now we are creating one dictionary called word count. We learned that the dictionaries are having the key value per. So key value per, this is the dictionary logic. For each key, we are having its corresponding value. For example, if we are having the word count, we are having, for example, first key is hello, and its value is 1, for example. It means that for the key hello, we are having its corresponding value 1. And here in the output, for example, we are having the key hello and its corresponding value is 2. Why? Because 2 represents the number of repetition of hello. So we need to create a dictionary that is created of key value per. So it is going to help us to understand how many times a word is being repeated. So now we are having a for loop. For each word in words here, okay, so word is my iterating variable, words is my variable here. We are iterating through each word of this sentence. So we are, first of all, this is hello, then in the second iteration, my word is word, then in the third iteration it's hello, then it's everyone, etc. Okay, so let me write it down. In the first iteration, word equals hello. Second iteration, word equals word. Then third iteration, it is equal to hello again until the end. Okay, we are going to iterate through each of these words one by one. So in the first iteration now, word equals hello. We are going to see if this word, which is hello, is in the word count dictionary or not. It's not, because we just created it and it's an empty dictionary. So it's not. This one is false. This part is not executed. Therefore, we are creating the key in the word count dictionary and assign its value to be 1. So our dictionary was empty. Now we are adding the key, which is hello, to the word count dictionary, and its corresponding value is 1 now. Why it is hello? Here is word. Why it is hello? Because in the first iteration, word equals hello. Okay? So this is how. Then we go for the next iteration. In the second iteration, word equals word. So we check to see word, is it in the word count dictionary? No, in my word count dictionary, I just have hello and its corresponding value. So this part is not executed because this part is false. Then we come here. When we come here, we see that, okay, we need to create a new key with its corresponding value. So a new key is our word in the word count dictionary, and its value is 1. So it means that we are going to have word and its corresponding value is 1. Okay, so we are having the iterating variable being inserted as the key, as the next key of the word count dictionary, and its value equals 1. Its value equals 1. Because, and why we are having the word here? Because we are iterating in this, we are in the second iteration, and this word equals word in the second iteration. So we go up back. So we go for the third iteration. The third iteration, we are having the third word, which is hello again. So we check to see if this word is already existing in the word count dictionary. Here, do we have hello? Yes, we have one hello. Okay, we have one hello. So this part is true. and we are going to add one value to the key of the word count dictionary. And what is that key? That key in the third iteration is hello, and hello is already there. So we are adding one value to its value. So value is already one. We are adding one value, it will become two. So we are adding one value to the word key, which is in the first iteration hello of the word count dictionary. Okay. So this is how we are having now hello 2. Then we go up, then the next word is everyone. So everyone, its value is 1. This is, for example, then counted, and then until the word. So when we are having the word again, so we already had one word, we are going to increase this word to 2, and then we are going to continue with the rest of them as this logic. So we learned that in this video, first of all, we lowercase all the letters, and the reason is because if we are having one hello with capital H and one hello with lowercase h, it is going to consider both of them to be equal. So now we are going to lowercase everyone. So this one is also hello now. So the compiler will see them as uh, one similar word. But when we are having one h which is large, which is uppercase, the compiler differentiate this one with this one because the compiler is sensitive with the capital or small letters. So this is why we had the lowercase. Then we have the split because we want to split this sentence into words. We assign it to words now. We create a dictionary which is empty. We loop over the words inside the words. Here we check and we remove the punctuation. So whatever that we are having, question mark, comma, the period, etc., all of them are removed, and we are updating the word here. Then we are going to check to see if that specific word in the first iteration hello already exists in the word count dictionary or not. So it's no. We are going to insert it for the first time and assign the value 1. Then in the next iteration, when we encounter hello, for example, we see that okay, hello was already there, and we are going to simply add one value to its value. Now it's 2, etc. So until the end, we can count the number of occurrences of each word in a given sentence. Thank you for watching.